Bringing inquiry into my classroom. Veronica Vasquez, ECD 322, Cognition and General Knowledge, Science, Math, Logic, and Reasoning, Catherine Casey, February 22nd, 2026. What is inquiry in early childhood? What is inquiry? Inquiry is children observing, questioning, exploring, testing ideas, and reflecting. It follows the cycle of inquiry, observe, question, investigate, and reflect. Inquiry is child-driven but teacher-supported. Why inquiry matters: builds problem-solving and critical thinking, supports STEAM learning through hands-on exploration, encourages rich language and deeper thinking. How can I bring inquiry into my classroom? Free play, outdoor spaces, routines, intentional materials, and questioning in family partnerships. And then inquiry notes. In early childhood means children are actively exploring the world through curiosity. In my classroom, inquiry happens when children observe something, ask questions, test ideas, and reflect on what they discover. According to the NAEYC cycle of inquiry, learning moves through observing, questioning, investigating, and reflecting. I see this cycle naturally happening when children experiment with blocks, water, or outdoor materials. Trundle explains that early science experiences build foundational thinking skills and support long-term academic success. The National Science Teachers Association also emphasizes that early science education should be hands-on and developmentally appropriate. I believe inquiry gives children ownership of their learning rather than just receiving information. Strasser discusses how open-ended questions stretches children's thinking. In my classroom, I intentionally use open-ended questions to deepen exploration instead of giving answers. Bringing inquiry into free play. Inquiry during free play. Children explore, test ideas, and problem solve through play. I observe first, then extend thinking with open-ended question. STEAM learning happens naturally in centers. Learning experiences within materials. Block area, blocks, measuring tape, balance scale, sensory table, water, funnels, measuring cups, art area, color mixing trays, droppers, dramatic play, measuring spoons, thermometers, and clipboards. Questions that I ask: how will you make your tower stronger? What do you notice when the water moves faster? And then what do you think will happen if we mix these colors? And then why free play matters. Open-ended questions stretch thinking. Hands-on exploration builds science. Understanding. Play-based STEAM reduces intimidation and supports curiosity. Bringing inquiry into outdoor spaces. Inquiry during outdoors. Outdoor play provides real-world science experiments. Children observe, test ideas, and explore cause and effect. I extend learning through intentional questioning. And then learning experiences and materials, ramps and balls, exploring speed and gravity. At nature walks, leaves, rocks, magnifying glasses, water play, buckets, funnels, measuring containers, weather observation, clipboards, drawing journals. And then questions that I would ask would be: what happens when we lift the ramp higher? What do you notice about this leaf? And why do you think these clouds look different today? And then why outdoor matters. Hands-on science builds reasoning skills. Early science develops observation and prediction. And then place-based STEAM supports curiosity and confidence. Bringing inquiry into routines. Inquiry during daily routines. Inquiry happens beyond centers. It's embedded in snack, transitions, and bathroom time. Children observe, predict, measure, and problem solve during everyday moments. I use intentional questioning to extend thinking. Learning experiences and materials, snack time, measuring cups, pictures, equal portion discussions, bathroom area, visual step charts, water flow observation. Transitions would be timers, counting steps, predicting cleanup time. And questions I ask: how could we fill the cups evenly? Why do we have to push that button to flush? And then what happens if we pour too much? And then why routine matters. Math and science are embedded in daily life. Open-ended questions deepen thinking. And then STEAM learning happens through meaningful experiences. Materials and classroom setup. Inquiry in STEAM materials in my classroom, science center, magnets, magnifying glasses, scales, natural materials, rocks, leaves, shells, simple experiment trays, block math area, variety of blocks, wood, foam, hollow, measuring tapes, rulers, balance scale, art area, color mixing trays, droppers and paint, recyclables for building, and then dramatic play, measuring spoons and cups, play thermometers, clipboards for recording observations, and then why placement matters. Materials are accessible and open-ended to invite exploration. Environment encourages hands-on science learning, and then play-based STEAM builds confidence and curiosity. Children in my classroom naturally move between centers, testing ideas and revisiting materials by intentionally placing STEAM materials across all areas, not just the Science Center. I encourage inquiry throughout the day. Planning for daily inquiry. How I plan for inquiry daily: observe children's interests and developmental levels, plan open-ended questions ahead of time, embedded STEAM materials across centers, and then reflect and adjust based on observations, considering children's needs, developmental stage, scaffolding support, language abilities, clear open-ended prompts, and then individual interests, building nature, water. When and where inquiry happens, center time, blocks, art, sensory, outdoor play, transitions and wait times, small group discussions, and then why intentional planning matters. Developmentally appropriate science supports learning, assessment guides intentional instruction, meaningful science is built into daily experiences, and I collaborate with my co-teacher weekly to review observations and plan materials that extend children's curiosity. I also use assessment notes to identify skills that need support, such as prediction, vocabulary, or problem solving. And inquiry is not spontaneous, it is intentionally embedded into our daily routines and learning environment. Engaging families with inquiry. Explaining inquiry to families, inquiry learning through curiosity, exploration, and questioning. Children observe, predict, test ideas, and reflect. And then STEAM learning happens through everyday experiences. And then why family partnership matters. Early science learning begins in everyday experiences. Conversations that stretch thinking, support development. And then play-based STEAM builds confidence and curiosity. In my classroom community, many families are unsure what STEAM looks like in preschool. I explain that inquiry is not worksheets or experiments, it is children asking questions and exploring the world. By sharing examples and simple question prompts, I help families feel confident supporting inquiry at home. When and how I share this, it's monthly newsletters with photos and children's quotes, parent teacher conferences, documentation boards outside the classroom, back to school night explanation, and then encouraging inquiry at home. Ask open-ended questions. What do you notice? What do you think will happen? And why do you think that? Explore during cooking, bath time, or nature walks, and then encourage children to explain their thinking. Reflection and AI use statement. Through this process, I learned that inquiry is not a single activity, but a mindset that guides how I plan, question, design my classroom environment. I now see how intentional questioning and material placement support children's natural curiosity every day. Creating this plan helped me recognize that inquiry is intentionally embedded throughout the entire day, not just during Science Center time. The Module 6 readings reinforce that children are capable scientists when we provide meaningful hands-on opportunities. The NAEYC cycle of inquiry reminds me that children learn through observing, questioning, investigating, and reflecting. I have grown in understanding how my role is not to provide answers, but to guide thinking through intentionally questions and responsive planning. This reflection represents my own teaching practices and how I support inquiry in my classroom community. And then AI statement, AI tools were used for this editing support. All reflections and ideas are my own. And then here is a list of all my references that I used within the slides and from the course readings. And I hope you enjoyed my video. Thank you.